start the recording again here. So hopefully we didn't lose too many people here. Again, my name is Nick Klosky, and I'm co-founder of Honeypoint 3D, and I welcome you to the May 2018 monthly 3D printing and 3D design webinar. For anybody who stayed on, I see that there's maybe a couple people who stayed on. I appreciate that. And if anybody else has any questions who's watching this maybe on the replay afterwards, then I encourage you to just email me personally, and I can help answer those questions. So with that said, and actually let me bring up my video here so that people online in the replay can see myself. I'm going to go over some things this month that people have asked about Meshmixer and some cool things about the BLK360, some laser scanner things, some fusion things. But if anybody online has any questions, I am very, very happy to answer them. So use the question and answer feature on the left-hand side to ask your questions, and I will be very happy to answer them. The first one started off is actually I got a question about Meshmixer on how to attach objects to other objects using Meshmixer, and this is actually in the physical world, not in the digital world. So let me hopefully this is where the webinar kind of went south last time. So, but let me see if this will work this time. So I brought up Meshmixer here, and the question is how to attach things to other things in the physical world. I'm just going to import a plane right here like this. You can see it's just a plane. I'm going to kind of select the center part and hit D for extrude and extrude this guy out. Maybe 15 millimeters, and then I will plane cut the bottom like that. So we just have kind of a nice little kind of block right here. And I'm going to hit T for transform and D for duplicate. So now we have kind of two blocks, as you can see. And view the browser. All right, so we have two of these blocks, and how would we kind of connect these together? I'm going to make one of those disappear. Well, Meshmixer has some built-in things to kind of help you with that. If you click on Meshmix right here, and you go to miscellaneous, there's these pins right here. So this is a pin, and this is kind of a hole for the pin. If we drag this onto our object, kind of a little bit too big, but we can say that the dimension of this will be maybe 10 millimeters, and click accept. And if we click Meshmix and drag a pin onto here also for 10 millimeters, like that, we have these pins in here. Now obviously what you can do with this is pretty easily, we have our pins right here, is select this one and this one. I'm holding down the control key. I made sure to select the second one, the pin part second, and then just do a Boolean difference. And what that will do is cut that hole in here. Now, because I sized these in the same way, if we move this over, you see that there's kind of a gap around the edge. But I think what this is designed to do is that when this goes in, there's actually a ridge down there at the bottom. If we move this up, you can see a ridge kind of down here where this is meant to kind of click inside and hold it. Now, this is a rotational pin, so these objects will be able to rotate around each other, but it would be a way of attaching these. If you had two of these pins, like one over here and one over here, then they wouldn't be able to rotate around each other. Kind of a good rule of thumb when using things with 3D printing is to know the tolerance of your objects. So when we Meshmix in a pin right here and we bring it in as 10, right, this will be kind of the exact size for the ridge at the top to fit in the ridge right here, because these are, appropriately sized. Your printer might need a little bit more tolerance, so you can always say, 10.2, right, and make it a tiny, tiny bit bigger so that when you do the Boolean difference, I selected the wrong one. When you do the Boolean difference of this one and this one, that you have a tiny bit bigger for this to slip down. That's just something that is kind of unique to your specific printing processes. If you're using a very, very accurate printer, you may not need to do that, but that might be a good way to connect, these two pieces together, and then you would do you would move this down and then do a Boolean on that. Now, as you noticed, the Boolean kind of disappeared. It made that cutting tool disappear. If I undo this a few times, this disappears when we do the Boolean. So what's a good kind of rule of thumb is that when you know that this is going to disappear, you click on this little icon down at the bottom, which is a duplication, and you can see that we duplicated it. Now we can click on these, do a Boolean difference. We don't really see anything. We click accept, except if we hide this one, we now see that a Boolean happened right there, but we still have the part in the same place. We bring this one down, to wherever we would want it to connect, and we could be a lot more accurate than that. And then we could even hide the bottom one, and we do the same thing as we select this one and this one, do a difference. And now when a pin goes in here, it would go, let me turn on a different shader to show you. It would show that it would go right inside of there, and that would be a kind of a perfect match. If you put in two pins like this, and again, you would need to test for tolerances, it would effectively pretty much lock. It wouldn't be the most strongest lock in the world, but it would be pretty strong if you were connecting these two things together. So hopefully that helped answer the question from one of our users about how to connect. In this instance, it was plates of different shapes that were kind of stacking on top of each other. That's not the most robust way of doing it because there's still be a little bit of movement, but you could play around with that, and that's kind of an easy way that's built in to Meshmixer. I want to see if anybody has any questions online. If they don't, then I will go to the next thing I want to talk about. So I have been playing around. It'd be nice if I could make this video bigger, but I guess I can't. I have been playing around with this. I don't think I could actually. This might break the webinar, but let's see. No, I can't do it. But anyway, what you might be able to see here is I've been playing around with this, which is a laser scanner from Leica. It's the BLK360. You can kind of see the mirror inside of this. And this sits on a moving plate, and it spins. And as it spins, and it's actually spinning a mirror and creating a 3D model of wherever you are. So I kind of wanted to show what that looks like. If we go here, this is an example of a model that is created with the BLK360. And it's of a home out here for one of my family members. And it's pretty awesome. This took me probably an hour or an hour and a half to capture this. And if we zoom in here, you're actually able to go inside the walls and see a really nice house. And this is, although it looks kind of solid, if we zoom in more, you see that there are just points in space. And some of the points get taken away just for performance, but then when you stop, all the points get filled in. And if I click on these bubbles, it actually goes into photographs that were taken of a very nice room here. And the very awesome thing about this is that this is all a full 3D model. So if I click, I can actually say the distance between this painting and this painting right here is 1.842 meters. and I can, take different measurements out, different places. I can kind of play around with, if you kind of see, it'll show the, I'm pointing at the screen. It'll show different dimensions when you hover over these things. And it's very, very cool, very, very useful in a lot of ways. Go back out here. And, if we go through, we see, different hallways, stairs, very useful for measuring. If we click and kind of go in here, you can even, if you looked in here, I clicked on this pipe and this banister railing, and it actually is able to do a measurement. As you can see, what the diameter of that is. It's actually set to meters now, so 0.03 meters, which would be about 38 centimeters, or 0.03. Yeah, so 3 centimeters, 38 millimeters, something like that, is the diameter of that pole right there. So that is pretty awesome. I wanted to kind of bring this back to how to use this with Meshmixer. You can go in and turn any of this into a 3D model. Make sure there's no questions right here. And turn this into a 3D model, which I have actually done. So if we go into here to Meshmixer, and I'm going to import, replace, go to my desktop right here. I did this for my home garage, which is pretty awesome. And it's actually very useful. I did this because I wanted to figure out where to hang one of my bicycles in my garage. I don't really have space on my floor, so I created a 3D model of my garage. And that's kind of my garage door opener, as a kind of a blob there. But this is very useful to go in and say, this is kind of where my garage door comes down, and kind of orient it like this. The garage door opener extends here, and I have some other, these are actually fluorescent lights up here that are at the top of my garage, and I have a little bar hanging off, and then kind of an attic space. That's actually a painting that's in my garage, and I can use this to do some modeling. If we say dimensions, it's accurately dimensioned, so almost 5,600 meters. So almost, millimeters. So about, 6 meters, something like that, 18 feet around here. And I can do things in Meshmixer with this, or I can bring it into Fusion, which I have done. Let me properly size this so that everybody online can actually see more, but for the replay people, I want to properly size this like this. But now we have, this is in Fusion, a model that is properly sized. So I can do things with creating sketches. If I set my sketch plane properly, I can actually, I click the slice button right here so that I'm only seeing exactly where my my STL is, and I can model off of this. I can also do something, actually, let me go back out. The way that I would probably actually do this is I would say sketch a create mesh section right here. I would do it on this body. And then I would, probably want to go something like this, and I would put this mesh section wherever I thought it would be. And actually, the way that I would probably do this is I would do a mesh section right on, probably at -1 degrees, maybe -2 degrees, probably 1 degree right there, right on that bar, or actually that beam. Now if I turn off the mesh body, you see that I have the beam line. And I can say sketch mesh fit curves to mesh section for this. And what I would do is I would say I just want this to be a straight line from about here to here. you know, and I'm not doing this entirely accurately. I would probably want to refer back to the original scan, but just for demonstration's sake, I would say okay. And you see I have a section here. I don't need that anymore. And now I have this awesome line. And so this line I could use. I would create another probably mesh section going perpendicular to kind of see where the roof line is. But from this line, I could, actually, let me do it. I could say construct plane. I don't even need to do a plane at angle, but I could. I'd say I want to come down at, you know, probably a 90-degree angle from here. Well, now it occurs to me that I already did this, but anyway, I could slice this. So now you can kind of see that those lines were actually the fluorescent lights, so I don't really need this. But this is something where I could create different lines that come down. I would bring this line in, and, you know, I could create all sorts of different, you know, bars to come down and up. Let me make this a little bit more opaque. Like this, opacity, I'll just turn it down to 10% so I can see through it and go back to my sketch right here. And so I can offset this, you know, something like that. And if I wanted to build something that would go here, I could now kind of take this out and extrude it, you know, a little bit. I could see what would fit maybe on the bar, so direction is symmetric. You know, something like this I could see would still kind of fit on that bar up here. I mean, it would come down quite a bit ways, but, you know, this would start to give me a template for building something inside of that space. And all of these are properly dimensioned. Pretty darn cool. So that's kind of some things I've been doing with the laser scanner. Now, the laser scanner itself, if I kind of bring myself back here, the laser scanner itself is pretty pricey, right? So it's about $18,000 to $22,000, but that's all relative, right? Because the price for scanners kind of before this one came out were about $50,000 or $35,000. So this is more of a deal at $18,000 to $22,000. But just kind of some very useful things you can do with a laser scanner like that, and then being brought into Fusion. I just want to check and see if anybody has any questions online. I like to try to keep these around, you know, half an hour so that I don't kind of waste too many people's time with things. But I also want to be aware that people are watching online after the fact, and I am open to having questions posed to me. I'd like to kind of put my my email address just up on the screen here. So it's nick@honeypoint3d.com if you want to ask any questions about, for the next monthly webinar, or if you have any questions about rapid prototyping or design. I just want to make sure that people get this email address just in case they need it. So I'll take that down like that. Well, if nobody has any questions online, I just wanted to talk about one more thing in Fusion that I found is very, very useful. And I switch back to Fusion here. A while ago, we talked about creating some text on curved surfaces in Fusion. And just one of the updates, I get this question actually quite a lot because it's kind of a normal thing to ask for. But here's kind of a new way that Fusion makes it a lot easier than it used to be. I'm just going to go into the create form area right here and just create some sort of, box and make this a little bit more wavy like this. And I'm going to right click and say edit form. Now I'm going to make this, more wavy in different ways. I can kind of move this up and down and out and over. So that's a very kind of organic type shape right here, as you can kind of see. Now in the past, if you wanted to cut letters into this, it was very painful. You had to sketch some text and then split the face and then offset each letter of the face. No longer. If you go to Sketch and sketch some text, the only thing you need to know is that you want to sketch on a sketch plane, and you want to have the text completely inside of the area. Let me maybe put this at 20. That is violating what I said because part of this is going outside. So just to make this work, let me make this a little bit smaller inside of the area. And you click Stop Sketch. Now this is still just a text object. It's no different than anything. But if I hold down my mouse button and then select text and then right click, you'd say press pull, but it actually starts the extrude button or extrude tool. Now you can say, a normal cut of the text. You don't have to explode it or anything, which is very nice. It's doing kind of cuts, so you could certainly cut that out. But the very nice thing now is, the very nice thing now is you say to object, and you can say to this face. And now, as you see, it is defaulting to cut, but you can say join. And if you just do it with that, then nothing actually happens, except you can say an offset of maybe 0.25 millimeters. And again, Fusion should think about it for a second, and you click OK. And after a little bit more thinking, Fusion has now made this very nice. So it's coming out 0.25. It's all still parametric, you can see right here. And it's coming out 0.25 based on wherever it hits the surface. Now you can do the same thing with cutting. Let me do an offset plane here from the origin. If you start out here and do some text, so you see we're kind of outside, we'll say outside, and make this a little bit bigger. There we go. You see we're outside of the area, and I'm going to right click on this and say press pull. Again, distance, we'll say to this face. And since it's going just to the face, you are creating it because it hasn't gone inside of the face yet, so you're not activating a cutting tool. If you actually drag it, you would actually start to cut, but you would be cutting at a flat termination plane. So what you can say is distance to, and then an offset of 0.25, or actually offset of negative 0.25, and say OK. Fusion will again think, and we have this awesome cut in this, and it is still parametric. If you go and change the sketch and double click on this because it is still text, outside to, click OK, and stop sketch. Fusion will think about it and update it. Very, very nice parametric for essentially extruding to a surface with an offset, or extruding from the inside of a surface with an offset. So pretty cool. It used to be a lot harder, where you had to set up your object, you had to split the face, and then split the face for every single letter, and then press pull each and every single letter. Very not parametric, prone to failures, and no more. It actually works a lot better now. So I just want to kind of share that. A lot of people ask about how to cut text. Now that doesn't work about how to cut text like around an object, but that is handled by the sheet metal functions, and there's a lot of tutorials online that show how to do that. It's kind of hacky. It's not meant to do that, but people have found some really awesome ways of using sheet metal to essentially fold something flat, and then you write some text on it, and then the sheet metal will actually rebend it and turn it into a cylindrical object, which is pretty nice. But it is kind of a hack around the tool, but it totally works, totally valid. Want to see if anybody has any questions, and if not, then I'll keep this to half an hour minus the time that it took to get our technical things sorted out. And I invite people to email me throughout the month. I'm working on some updates to the Fusion class, as well as I already put out some updates to our Mesh Mixer classes at education.honeypoint3d.com. And I just really thank you, all of our users, and look forward to getting your questions for next month. Thank you so much, and hope you have a great day. Bye-bye.